Hello, everyone, and welcome. I'm excited to kick off our presentation today. We're going to explore the fascinating world of visualizing solid shapes. The title of our talk is Visualizing Solid Shapes, and as we go along, we'll look at different ways to understand and visualize these three-dimensional objects. We'll cover key concepts, techniques, and some interesting examples. So, let's get started and dive into the world of solid shapes. Let's take a quick look at the contents of today's presentation. We will start with an overview of different shapes, both 2D and 3D then. We'll explore what exactly a shape is and how to identify and differentiate between plane figures and solid shapes. We'll look at some examples of each to solidify our understanding. Next, we'll focus on 3D shapes specifically, discussing their key features like vertices, edges, and faces. We'll see how to visualize these solid shapes from different perspectives, which is really important for understanding their structure. We'll also look at how to observe and interpret different views of solid shapes, like the top, side, and front views, especially when it comes to objects like cubes. And finally, we'll wrap up with a summary and some concluding remarks. Throughout this presentation, the goal is to build a clear understanding of the geometric shapes around us and how to visualize them in 3 dimensions. Now, let's take a closer look at what shapes actually are. When we talk about shapes, we're referring to the form or outline of objects, whether they're flat or 3-dimensional. This is fundamental because understanding shapes helps us visualize and describe the world around us more effectively. Moving on, an important aspect of understanding shapes, especially in 3 dimensions, is knowing about faces, vertices, and edges. Faces are the flat surfaces that make up a solid shape. Vertices are the points where these faces meet, and edges are the lines where 2 faces come together. Recognizing these components helps us analyze and differentiate various solid shapes. Next, we'll explore the difference between 2D shapes and 3D shapes. 2D shapes are flat and only have length and width. Think of circles, squares, or triangles. They are easy to draw and visualize on a flat surface. In contrast, 3D shapes are solid objects that have depth in addition to height and width. Examples include cubes, spheres, and cylinders. Understanding how to view these shapes from different angles or perspectives is crucial to grasping their true form. This leads us to the idea of views of solid shapes. When we look at a solid object from different angles, it might appear different depending on our viewpoint. Learning how to visualize these views helps us understand the shape's structure better. Finally, we'll discuss how to visualize a solid shape. It's about imagining the shape in 3 dimensions, rotating it in your mind, or even sketching different perspectives. This skill is key to understanding and working with complex shapes in both everyday life and in technical fields. Let's talk about what a shape actually is. A shape is basically the form of an object or its external boundary, outline, or surface. It's what defines the outer appearance of something. Now, it's important to note that shape is different from properties like color, texture, or the material something is made of. These are all different aspects, but when we focus on shape, we're really looking at the overall form and boundaries. Psychologists have also studied how we perceive shapes. They've proposed that our brains tend to break down complex images into simple geometric components called gens. These are the basic building blocks of shapes. Think of cones, spheres, cylinders, simple forms that our minds use to understand more complex objects around us. Understanding shape is fundamental because it connects to how we recognize and interpret the objects we see every day. By grasping the concept of gens, we see how our visual system simplifies the complex world into manageable pieces. This idea ties directly into our overall theme of perception and how we make sense of our visual environment. Now let's explore 2D shapes or plane figures. These are flat, geometric figures that are made up of either straight lines or curved lines. The key point here is that they only have length and width, or in other words, their breadth. Unlike 3-dimensional objects, 2D shapes do not have any depth, so they are completely flat. Some common examples include circles, triangles, squares, and rectangles. You might also have seen shapes like ovals, diamonds, rhombuses, and parallelograms. An important concept to remember is that shapes made up of 3 or more straight lines are called polygons. Understanding these shapes is fundamental because they form the building blocks for more complex geometric concepts. Recognizing these shapes in everyday life helps us see the connection between geometry and the world around us. So, as we proceed, keep these key shapes in mind, as they'll often come up when discussing other geometric ideas. Let's take a closer look at some examples of 2D shapes. As you can see, shapes like polygons are quite common and come in many forms. For instance, triangles are the simplest polygons with 3 sides and 3 angles. Moving on, quadrilaterals are 4-sided shapes, and some familiar examples include squares, rectangles, and even trapezoids. Then we have pentagons, which have 5 sides, and hexagons with 6 sides. Think of honeycombs. Circles are unique because they are curved shapes with no sides or angles, but they are still an important part of 2D geometry. Lastly, we see octagons, which have 8 sides, often seen in stop signs. Understanding these different shapes helps us see the variety and structure in everyday objects and connects directly to how we analyze and recognize shapes in our environment. Recognizing these common shapes is a key step in mastering the broader concepts of geometry that we're exploring today. Now let's talk about 3D shapes or solid shapes. A solid shape, as the name suggests, has 3 main dimensions: length, width, and height. Because of these dimensions, it actually takes up space and rests on one or more surfaces. Think about objects around us, like a cube, a cone, a sphere, or a cuboid. These are classic examples of solid shapes. Many real-world objects resemble these shapes too. For example, a book or a laptop is similar to a cuboid, a ball is like a sphere, and a birthday cone resembles a cone. Recognizing these shapes in everyday objects helps us understand their properties better. Some common types of 3D shapes include the cuboid, sphere, cone, cylinder, pyramid, and cube. Each of these has unique features, but they all share the characteristic of occupying space in 3 dimensions. Connecting this to our overall theme, understanding solid shapes helps us see how geometry appears in our daily lives and the objects we use every day. Let's take a look at some common examples of 3D shapes. First up is the cube, which has 6 equal square faces, 12 edges, and 8 vertices. It's a perfect example of a shape with equal sides and angles. Moving on, we have the sphere, which is completely round and smooth, like a ball. It has no edges or vertices, and every point on its surface is equally distant from the center. Next is the cylinder, which has 2 parallel circular bases connected by a curved surface. Think of a can or a pipe. Then there's the cuboid, also known as a rectangular prism, which has 6 rectangular faces. It's similar to a box and is very common in everyday objects. The cone is a shape with a circular base that tapers smoothly to a point called the apex. An example would be an ice cream cone. The last shape is the square-based pyramid, which has a square as its base and 4 triangular faces that meet at a single point above the base. These examples help us see the variety of shapes in 3 dimensions, each with unique properties that make them useful in different contexts. Recognizing these shapes is fundamental to understanding more complex structures and design principles. Let's talk about faces on solid shapes. Every single surface of a solid shape is called a face. For example, if you look at a cube, it has 6 faces, 1 on each side. Now, take a moment to observe the figure shown below, which highlights a face of a cuboid. As you can see, each face is a flat surface, and understanding these faces helps us better comprehend the structure of 3-dimensional objects. Recognizing faces is a fundamental part of understanding how these shapes are built and how they differ from each other. So, whenever we analyze a solid shape, identifying its faces is one of the first steps. Let's talk about vertices in a solid shape. A vertex is essentially a point where 2 or more lines come together. It's like the corner of a shape where edges meet. When we talk about multiple vertices, we use the plural form, which is vertices. Now, an interesting exception is a sphere. Since a sphere is perfectly round and smooth, it doesn't have any vertices at all. If you look at the figure on the slide, you'll see an example with a cube. The points where the edges meet are the vertices of the cube. Recognizing vertices helps us understand the structure of three-dimensional shapes and how they're built. This concept ties into the overall theme of understanding the key features that define different solid shapes, making it easier to identify and analyze them. Let's take a closer look at edges in solid shapes. An edge is essentially a line segment that connects two vertices or corners of a shape. Think of it as the line you see running between the points where the faces meet. For example, in the figure of a cube, each of those lines along the edges represents a connection between two vertices. Recognizing these edges helps us understand the structure and boundaries of three-dimensional shapes. As we explore more complex solids, understanding their edges forms a foundation for grasping their overall geometry. So, whenever you're analyzing a shape, identifying its edges is a key step in understanding its form and properties. Now, let's talk about the views of solid shapes. Every solid shape we study has three main views: the top view, the side view, and the front view. These views help us understand what the shape looks like from different perspectives, which is really important in fields like engineering and design. Starting with the top view, this is what you see when you look directly down at the shape from above. It gives us a clear outline of the shape's footprint or the shape's shape from above. Next is the side view. This view shows us what the shape looks like from one of its sides. It helps us understand the height and the side profile of the object, which might not be obvious from the top view. And finally, the front view. This is what you see when you look directly at the front of the object. It reveals the shape's front profile, giving us another important perspective to understand the overall form. By examining all three views, we get a complete picture of the solid shape, which makes it easier to visualize and work within real-world applications. Remember, these views are essential tools that connect the three-dimensional object to two-dimensional drawings, helping us communicate clearly about complex shapes. Let's take a closer look at the cube shown here. As you can see, we've got three different views: the top, the side, and the front. These views help us understand the three-dimensional shape more clearly. When we observe the cube from the front, we see one face directly facing us. From the side, another face is visible, giving us a different perspective. And from the top, we see the upper surface of the cube. This multi-view approach is really important because it helps us visualize the actual 3D object more accurately. By understanding how these views relate to each other, we can better grasp the overall shape and structure of the cube. Think of it as putting together a puzzle. Each view provides a piece of the puzzle. When combined, they give us a complete picture of the object. This is a fundamental concept in technical drawing and design, where visualizing objects in 3 dimensions is key to understanding and communication. So, by mastering how to interpret front, side, and top views, we're building a strong foundation for more complex 3D visualization tasks. It's about connecting these perspectives to see the entire shape clearly. Now, let's explore how we can visualize a solid shape in different ways. Visualizing a solid shape isn't always straightforward, but there are some effective techniques that can help us understand its form better. One way is by cutting it, which allows us to see inside and understand its internal structure. Imagine slicing through a block of cheese or a cake. This gives us a clearer view of what's inside. Another common method is visualizing the shape by its shadow. Shadows can reveal the outline and depth of a solid object, especially when viewed from different angles. These methods are important because they help us grasp complex shapes more intuitively, and they tie into the larger theme of understanding and representing 3-dimensional objects in a more accessible way. So, whether through cuts or shadows, these visualization techniques are key tools in our geometric toolkit. Let's wrap up our presentation by exploring how we can visualize solid objects. The key idea here is to imagine the smallest possible unit that makes up the object. By doing this, we can better understand the structure and properties of the solid. Think of it as zooming in to see the fundamental building blocks, like atoms or molecules, that compose everything around us. This perspective helps us connect the dots between the microscopic and macroscopic worlds. Visualizing these tiny units allows us to grasp concepts like density, strength, and material behavior more intuitively. Ultimately, This approach is a powerful way to deepen our understanding of solid objects and their underlying makeup, tying everything we've discussed together in a more concrete way.